Okay, this is the last video I'm going to do on Riemann sums. This is going to be me doing some example questions. Okay, so I gave us a table this time. We don't have a graph, and that's why I really wanted to go over this. If we have a table instead of a graph, how do we do this? Well, and this is also going to go into different subintervals. We have this table. Our x variable or independent variable is t. Our dependent variable is h prime of t, which in this case won't matter for us, but it could matter. But let's see. We want to use part B. We want to use a right Riemann sum. Right Riemann sum. So that means we're starting at the right and going left, basically, with 5 subintervals. Since we're doing a Riemann sum, a right Riemann sum, we're talking about rectangles, so this basically means we want 5 rectangles. Using the data in the table to approximate the integral from 2 to 14. So since we're going from 2 to 14, we're using everything in our table. Okay, and when they give us a table, it's probably they're going to choose the whole interval, but they might not, so pay attention to that. So what is our x distance? Because we know we want 5 rectangles, so we know that we want 5 rectangles because it says we want 5 subintervals. The other piece that we need here is what is our x distance? Well, our x distance is from 2 to 14, so that's 12. 14 minus 2 is 12. So x distance is 12. So for each of these rectangles, oh, actually, I'm sorry, I take it back. This x distance doesn't matter in this case. Because I keep saying x, in this case we're doing t. Our t distance doesn't matter here because we have a table. Or not because we have a table, but because it doesn't say we want 5 even subintervals. Like if we look down here on part D, it's talking about subintervals of equal length. That's when we would be using this part here, but it doesn't say equal. So we need to divide this table into 5 rectangles. I'm going to do it in red. And I'm going to go ahead and start on the right because we're doing a right Riemann sum. So one rectangle is going to be from 14 to 10, or 10 to 14. I'm just going to go from the right. Our next rectangle will be going from 10 to 8. And hopefully, if everything works out, we should end up with 5. So this is one rectangle, this is one rectangle. Our next rectangle is 8 to 5. So this is 3 rectangles, 8 to 5, and then 5 to 4, so we're going 5 to 4, and finally from 4 to 2. 4 to 2. And that should have given us 5 rectangles. And let's check. 1, 2, 3, 4, 5. Yeah, we have 5 rectangles. Okay. So, and again, we're using the right endpoint. So I'm even going to go through and I'm going to circle the specific endpoints that I care about. Well, I care about this 14 for 1 for my red rectangle. It's going to be that one. For my blue rectangle, it's going to be, I'm looking at the right side of each of these. So my red one's this one, my blue one's this one, my black one is, I hope this does the right color. I think it will. This one. My green one is this one. And finally my pink rectangle. I think that was this color. Yeah, is this one. So we have our 5 endpoints of our rectangles. Okay, and now let's sort of put that into our thing. And this question is worth 3 points, and I'm going to go through what we need for each of the 3 points. Okay, so first off, we are approximating, so let's write that this integral from 2 to 14 of h prime of t dt is approximately, and then let's use our right Riemann sum. Well, our since we're doing a right Riemann sum, let's go ahead and go from the right. So we're starting with our red rectangle. So we want h prime of 14. That's the length of our rectangle. And I'm keeping it abstract for now, relatively abstract. Times our delta x. What is the distance between 10 and 14? Well, that's 4. So there's our first rectangle. And then I'm gonna let you try and keep going through with all the other 4 rectangles, and then when you come back, we should have the same equation. So you can pause the video now and try and write the rest of the 4 rectangles. Okay, hopefully that was enough time for you to sort of go through and get that on your own. And if you should have gotten this. So h prime of 14 times 4, because this distance is 4. H prime of 10 times 2, because 8 to 10 is 2. H prime of 8 times 3, because 5 to 8 is 3. H prime of 5 times 1, 4 to 5 is 1. And h prime of 4 times 2, because 2 to 4 is 2. And this right here, let's highlight it in, I'll do green. This specific part right here was 1 point. If you get that the thing should be this, you have 1 point right there. Okay, and now we've done all the hard work really. What we're going to do now is we're just going to start putting in numbers for all of this stuff. So again, well, I'll do the first one. H prime of 14 is 7.7, so we have 7.7 times 4. And we get that when it loads, that one. And we're just going to do this for all of them. So I'm going to go ahead, you can go ahead and pause the video, finish out the rest of it to see what you're going to get. Okay, and when you unpause the video, we should end up getting that. Substituting all our values in gives us this. 1, 2, 3, 4, 5. Yeah, 5 rectangles. And I actually realized I made a sort of notation error. Because this shouldn't be an approximately sign. This should actually be an equal sign. Because this is equal to that. You wouldn't lose any points for writing the approximately sign, but I'm just pointing that out now. That it was a small notation error. Okay, and we get all these numbers. If you successfully did this part right here, I'll highlight it in blue. This is your second point. And I'm going to do something a lot of y'all are not going to like. I'm not going to do anything more with this number. I'm not going to turn it into a single number because I'm multiplying decimals and adding stuff. There's just too much room for me to make a mistake. I don't have a calculator. This is a no calculator question. This is something that I'm going to call a safe stop, which means you can stop here. You do not need to simplify further, because if you simplify further and make a mistake, you're losing a point. If you stop right here, this is your point. And now where does the third point come from? Well, this third point is coming from a very small little piece in the question. This last part right here that I didn't read, indicate units of measure. Well, what is our unit of measure? And this is something I didn't super talk about in my videos, is units of measure. But we're talking about the area under the curve. We're talking about not the feet per hour. I mean, well, we are talking about feet per hour. We're talking about if we take all of the area under our feet per hour curve, it becomes a question of how much total feet did we travel? How much total, the word we use a lot is how much did our total dolphin population change? How much total did our water level change? We're just talking about this feet here. How much did our feet change? So our unit here is just going to be feet. And maybe some alarm bells are going off about a sort of connection between integration and something else we spent a lot of time on in this class with how the units change. But okay, so this was your third point right here. So 1 point for writing the right Riemann sum, another point for getting the correct value, which this is the correct value. It's not simplified, but it's the correct value. And then a third point for the unit. Okay, the next part, is this approximation an overestimate or underestimate? Give a reason for your answer. Okay, this is just something you need to sort of know off the top of your head. And it should be a free, this is worth 1 point. So it's either all or nothing for this. When we talked about right Riemann sums, and I can actually sort of draw a picture that might help us out a little bit. This picture is a visual representation of what's happening. This isn't actually going to be our answer. But what is h prime of t doing? Well, 0.3, 0.6, 0.7, 1.4, 2.3, 7.7. H prime of t is going up. It's increasing. So we have a function that looks sort of like this, which is actually it looks similar to the function I introduced us as. This is my sketch. This function is increasing. If we were drawing our rectangles, we start at the right. I'm going to try and draw my rectangles. It's not going to be perfect, but this is kind of even subintervals when we're not supposed to be, but if I draw my rectangles, what's happening? Are we over approximating or under approximating? Well, we can clearly see, if I will zoom in a little bit, this area all here we are overestimating. And if you want to draw that picture to help you out, you can. It takes a little bit of time, which time is a valuable resource. But if that helps you get the answer right, that helps you get the answer right. It's an overestimate because And it's overestimating because h prime is increasing. And this would give you 1 point right here. So we're at 4 points total so far for this FRQ. And I skipped part A because it wasn't relevant to us, but finally we're coming down to part D. This question is again worth 3 points here. Okay, and this one says we have our summation notation from k equals 1 to n of h prime of this ugly thing right here. I'm going to kind of ignore this ugly thing. Times 15 over n is a left Riemann sum with n intervals of equal length, n subintervals of equal length. So that means that n subintervals is n rectangles. And it's equal length, so we are going to have a delta x. And the limit of this sum as n goes to infinity can be interpreted as a definite integral. Express this limit as a definite integral. Okay, so we want to write this as a definite integral. So let's start by just giving the, working with what it tells us. Well, a left Riemann sum, we're working with rectangles. And so the area of a rectangle, and I'm going to use our fancy notation, not the simple notation, is our function value, so h prime of x times our delta x. This is our fancy notation for the area of a rectangle. And so I want to connect this to what we have here. So we have our h prime of this something, and then delta x, which, reminder, delta x equals x distance divided by number of rectangles if we have equal subintervals, which we do have equal subintervals because it says subintervals of equal length. So we have n rectangles. What is our distance? Well, our x distance is 15. That's important. X distance is 15. Okay. Actually, I'm sorry. I mean, I keep writing x because I'm used to working with x's, but this is not x. We're talking about t. So I should be writing h prime of t and delta t, not delta x, because I should match the variable that we're working with. Okay. So, what is our delta t? Well, our delta t equals 15 over n. Why am I writing that there? Well, it turns out this is actually one of your points. Noting that our total distance is 15 is worth a point. So I'll highlight that in yellow. This delta t equals 15 over n. I think I just did it, but it's not showing up on mine. We'll see. Yeah, okay. This is worth a point. You don't need this part in the middle if you want it, if writing it helps you, it's still true. But this part right here, that's worth 1 point. So we've already scored 1 point in this question. Okay. And now we want to rewrite this. We want to express the limit as a definite integral. So we need two pieces here. We need the limit and we need the definite integral. So our limit, well, it tells us the limit. The limit of this sum as n goes to infinity. So limit as n approaches infinity of our summation k equals 1 to n h prime of 15 over n times k minus 1 times 15 over n. So this is our limit. And guess what? We expressed the limit this part here. If we get this, this is another point right here, expressing that limit. So we've already gotten 2 points. Now our final point is expressing this as a definite integral. Well, we're going, remember when I said our x distance is 15? We're going from 0 to 15. This is our bounds of integration, if I want to be fancy with it. We're going from 0 to 15 because our x distance is 15 of, well, now it's just our function, h prime of t times delta t, or times dt, sorry. When we switch to integration, we start using dt. A differential is the fancy word for that. And this right here, let's see, I've done yellow, blue, I haven't done green yet. This right here is your third point. And I want to be really clear, if you don't put this 0 to 15, if you don't put the prime on the h prime of t, if you don't put dt, you're not getting that point. This needs to be exact. This part right here. 0 to 15. Okay. And there's our 3 points for this question. So it's not super bad. It's just rewriting this as an integral. Okay. And the final one we have, this is a different part. This is actually a multiple choice question, but I took away our multiple choice answers. Let me find it real quick so I can make sure I'm doing everything that I want to do. Yeah, this one right here. And I like this question because it's tricky. Okay. So it gives us a table with values, x values of a, random values of a, and then our function. And it says, very first sentence, continuous and decreasing. Those are 2 really important things to know. It's continuous and it's decreasing. The continuous we'll talk about more later, but the decreasing is what matters for now. A is a constant with 1 is less than a. So A is between 1 and 3. Let R be the right Riemann sum approximation for A to 12A. So we're talking about this whole thing using the 4 subintervals. Again, we're doing a right Riemann sum. So let's sort of draw our 4 rectangles. So we have 1, 2, 3, 4. So we have our red one, our green one, our blue one, and our black one. Hopefully those colors are showing up well enough. Maybe I'll zoom in a little bit. Yeah. Okay. So there's our 4 subintervals. Which of the following statements is true? Well, I'm not giving us the statements, but what I'm going to tell us is what I want us to do for this question is I want us to do 2 things. I want us to write the approximation and determine if it's an over or under estimate and y. That is what the answer choices are saying. The answer choices are having you write the Riemann sum and say if it's an overestimate or underestimate. So if you can do that without the answer choices, which you'd have to do this anyway, then we'll get the correct answer. Okay. So let's write our approximation. And so I'm just going to give us another bit. We're going to say R for our Riemann sum, our right-hand Riemann sum, equals, and what we're doing is a right-hand Riemann sum, so we're doing actually we'll give you the answer choices in a second once we've done this information, but we'll start with this. 10a to 12a. And we're using the right side, so we're doing what am I thinking of? F of 12a times our delta x, which is 12a minus 10a. And this is going to be our first rectangle. And I'll let you pause the video now, write out what the rest of the things are to see, make sure we're on the same page. And when you come back, I'll have all of them written out. Okay, coming back, and we should have gotten, I'm probably gonna have to zoom out a little bit here. We should have gotten this for all of the areas of our rectangles. The next thing we're gonna do is we're just gonna substitute stuff in. So, we're only going to substitute in what we know. We're not going to simplify anything that we don't have to simplify. So all I'm going to do is I'm going to say f of 12a, well, that's -1. So I'm going to have -1 times 12a minus 10a. And again, you can pause the video here, write out what the rest of these are going to be, and then come back and check in with me. And coming back, this is what we should have gotten for all of them. So we have our right-hand Riemann sum. And now we're just going to say, is it an overestimate or underestimate, and why? Well, I'll pause for a few seconds to let you make a prediction. Or not a prediction, let you come up with your answer, because we should be able to tell you and say what the answer is. And what we should have gotten is that this is an underestimate because f is decreasing. All right. And now we have all the pieces we need. I'm going to put the answer choices in, and we'll sort of look through them together. Okay, and now we have our 4 answer choices here. So let's start by, this is a lot of stuff to look at. Let's start by underestimate or overestimate. Okay, we said it's an underestimate, so we can already eliminate 2 answer choices. We can eliminate B and D, because the underestimate part you should also be able to come to without writing the Riemann sum. This is a right hand, our function is decreasing, it's an underestimate. So now, which of these will match what we have up here? So if we notice, these are in a little bit of a different order. They start with a squared minus a. So I'm going to look at my a squared minus a term. It's a squared minus a times 4. This one is a squared minus a times 5. This one is a squared minus a times 4. Obviously, that leaves us with C being our correct answer. So all I'm doing is I'm matching what term I'm looking at. And what they did is they wrote it from starting here to there. But I think it makes more sense for us to write it the other way. If you disagree with me, let me know, and I'll change that moving forward, because that would be helpful to know. And then let's look at A and figure out why it's wrong, just for sake of completeness. They do a squared minus a times 5. Well, a squared minus a times 5, that's looking at this left endpoint. This is just a left-hand Riemann sum instead of a right-hand Riemann sum. So it's a tricky answer. If you do a left hand instead of a right hand, you're going to end up getting this answer. Okay, and these are the only examples I really wanted to go over. I will give you some days to practice, or a day to practice in class specifically once we've done all 4 of these. But let me know what you think. If you have any questions, hopefully these are helpful. And this covers all of our intro to integration by Riemann sums.